Okay, so have you ever stopped to think about how your laptop, your phone, your smart TV, and maybe a gaming console can all be online at the exact same time, all through one single internet connection at home? Well, the answer is this really clever piece of tech called Network Address Translation, or NAT for short. Let's break down how this foundational but kind of invisible pillar of the modern internet actually works.
To really get why we even need NAT, we have to start with this number, roughly 4.3 billion. This is the total number of unique addresses that were available in the internet's original addressing system, IPv4. And back in the day, that seemed like an astronomical number. More than enough, right? Well, fast forward to today, with a global population of 8 billion people, and each person having who knows how many devices, you can see the problem pretty clearly. We just plain ran out of addresses. So how is the internet still running? How are we connecting brand new devices every single day? That's the exact problem NAT was created to solve. So here's our game plan. First, we'll dive into that address crisis. Then, we'll talk about what NAT actually is. After that, we're going to follow a single piece of data to see how it works step by step. We'll look at how it powers your home network, and finally, touch on its downsides and what the future looks like. All right, first up, the address crisis. You had this explosion of internet-connected devices, and it created a global shortage of unique public IP addresses. It's really that simple. Every single thing that wants to get online needs an address, and we were fresh out of digital real estate. So the solution involved creating two different kinds of addresses. On the right, you've got your public IP. Think of that as your home's unique street address on the entire global internet. But inside your house, all your devices use private IP addresses. These are more like apartment numbers. They only make sense inside your building. In fact, your neighbor's laptop could have the exact same private IP as yours. And here's the crucial part. These private addresses can't be used on the public internet by themselves. They need a translator. And that translator, that's NAT. It's this brilliant workaround that sits right on your router, and it acts as a kind of digital receptionist for your whole network. At its core, the definition is actually pretty simple. NAT is the magic that lets all those different devices on your private network, each with its own private IP, share that one single public IP address to talk to the rest of the world. And here's the key to understanding how it does it. NAT isn't just sitting there passively. Nope, it actively intercepts every single piece of data, every packet that leaves your network, and it actually rewrites the address information in its header. It's exactly like changing the return address on an envelope before you drop it in the mail. So let's really dig in and follow a single request from your computer out to the internet and all the way back to see this whole thing in action. Probably the easiest way to picture this is to think of an office mailroom. Your computer is like an employee sitting in a cubicle, and your NAT router is the mailroom clerk who handles all the outgoing and incoming mail for the entire building. Our little data packets journey really has three main steps. First, your computer sends out a request. Second, the router does its translation magic. And third, the router gets the response and translates it back so it gets to the right place. Okay, so here's our packet, fresh from your PC. The two most important parts for us are the source IP, which is your computer's private address, and the source port. You can think of the port as a specific doorway for an application on your computer. Now, if this packet went straight to the internet, servers out there would have no clue how to reply. It'd be like sending a letter with a return address that just says, John in cubicle 10. Totally useless. But the packet hits your router first. And the router's NAT function just springs into action. Look what it does. It swaps out the private source IP with its own public IP address. And it also assigns a new temporary source port number. Now the packet has a valid public return address and can travel across the internet. So how on earth does the router remember who to send the reply to when it comes back? Well, this right here is the secret sauce of NAT, the NAT table. It's a temporary log where the router basically makes a note. Okay, that request from internal device 192.168.1.10 using its port 52345, I sent that out using my public address on port 4001. This table is basically the router's short-term memory. So a moment later, Google's server sends a response. And where does it send it? It sends it back to the public IP and the port number it saw in the original request, which is, of course, your router. The packet arrives right at your router's digital front door. The router looks at that incoming port, 4001, checks its NAT table, and says, aha, I know exactly who this is for. It then rewrites the destination address back to the original private IP and port of your PC,
and forwards it along. And just like that, your computer gets the data it asked for, and it has absolutely no idea any of this translation ever happened. It's completely seamless. Okay, so that's how it works for one single connection. Now let's scale this up and look at the type of NAT that you are using every single day. This is something called Port Address Translation, or PAT. You'll also hear it called NAT overload, and this thing is the real workhorse. It takes the concept we just walked through and just scales it way up, allowing hundreds or even thousands of internal connections from all your different devices to all share that one public IP. It just gives each unique outgoing connection its own temporary port number in that NAT table. And that is the absolute key takeaway. This process, translating addresses and tracking all these different connections using ports, is exactly what your home Wi-Fi router is doing constantly for every single device you have connected to it. So while conserving those IPv4 addresses was the main reason that was invented, it actually came with some pretty fantastic side benefits. For one, it provides a basic layer of security just by hiding your internal network from the outside world. It also gives you network independence. I mean, you can switch your internet provider without having to go and change the IP address on every single device you own. It just makes setting up a network way, way simpler. Now, it's really important to clear up a common point of confusion. While NAT does give you a nice security benefit, mostly by blocking random unsolicited traffic from the internet, it is not a firewall. A firewall is a dedicated security tool that actively filters traffic based on a set of rules. NAT just translates addresses. Now, most home routers do both jobs, but they are fundamentally different things. But of course, NAT isn't a perfect solution. You have to remember it's a very clever patch for a fundamental problem, and like any patch, it comes with some pretty significant trade-offs. The biggest issue by far is that NAT breaks what's called the end-to-end principle of the internet. Basically, it makes it really hard for devices on the outside to start a conversation with a device inside your network. This is why some online games or peer-to-peer apps can have connection problems. They have to perform all these special tricks to get around the NAT barrier. It can also cause weird problems if someone else who gets assigned your same public IP later on gets that address blacklisted, which could end up affecting you. So let's just quickly recap the big takeaways here. First, NAT's main job is to translate private IPs into a single public one, which is what solved the address shortage. Second, it does this by using a translation table to keep track of all the different connections. And finally, the version you're using at home right now is called PAT, or NAT overload. And this all brings us to one last really fascinating question. You see, the long-term solution to this whole address crisis, IPv6, gives every single device on the planet its own unique public address. It seemingly makes NAT totally obsolete. So why, after all these years, is NAT still a fundamental part of almost every single network in the world? Now that's something to think about.